Hello students, in this lecture we discuss the solution of some results. Now our next question is prove that divergence of r raised to n into r bar is equal to n plus 3 r raised to n, and this question asked in 2018's paper. So here we prove divergence of r raised to n into r bar vector bar is equal to n plus 3 into r raised to n. So here we start our proof with the LHS side and we obtain the RHS side. So first of all here we obtain r raised to n into r bar. After that we find its divergence. So let's see solution. So first of all here we know what is our vector r bar. As we know xi cap plus yj cap plus z k cap. So first of all we find r raised to n into r bar. So that means here we multiply r raised to n with vector r bar. So vector r raised to n multiply with each term. That means r raised to n into xi cap plus r raised to n y into j cap plus r raised to n into z into k cap. Now our f1 term is r raised to n x. Our f2 term is r raised to n y. Our f3 term is r raised to n into z. Now we find the divergence of r raised to n into r bar. That means here we start our proof with the LHS side. Divergence of r raised to n into vector r bar is equal to, what is the formula? Del f1 upon del x. So here we write as the del f1 upon del x plus del f2 upon del y plus del f3 upon del z. So that means here we are doing partial derivative of f1 with respect to x. That means here we write as the del upon del x, or f1 term is the x into r raised to n plus del upon del y. Our f2 term is the y into r raised to n plus del upon del z. Our f3 term is the z into r raised to n. Now we are doing partial derivative of our function x r raised to n. But here we apply our multiplication rule of the derivative. Why? Because here contain the x and r raised to n is also function of x. So here we apply multiplication rule. મિત્રો આપણા જે ફંક્શન છે x અને r raised to n અને r raised to n પણ કેનું ફંક્શન છે x y z નું. So that's why here we apply the multiplication rule. તો મલ્ટિપ્લિકેશનના નિયમ પ્રમાણે પહેલા આપણે થશે x as it is Now we are doing partial derivative of x into r raised to n. So r raised to n as it is. Here we are doing partial derivative of x with respect to x. So 1 plus x as it is. Here we are doing partial derivative of r raised to n. So r raised to n થશે n into r raised to n minus 1. મિત્રો હજી આપણું ડેરિવેટિવ પૂરું નથી થયું. બાજુમાં r નું થશે del r by del x. So this is the partial derivative of our first term x r raised to n. r raised to n as it is x નું થશે 1 plus x as it is r raised to n નું થશે n r raised to n minus 1 અને બાજુમાં થશે r નું means del r by del x. Similarly here we doing partial derivative with respect to y and with respect to z. So again r raised to n as it is. Here we doing partial derivative with respect to y, તો y નું થશે 1 plus y as it is r raised to n નું થશે n r raised to n minus 1 dr by dy plus now we doing for last term r raised to n as it z નું થશે 1 plus z as it is r raised to n નું n r raised to n minus 1 into del r by del z. Now we substitute, as we know value of del r by del x, del r by del y and del r by del z. So here we substitute this value. This is the r raised to n. Now observe r raised to n, r raised to n, r raised to n. So 3 times r raised to n plus x n r raised to n minus 1. What is the value of del r by del x? Del r by del x is the x by r plus y n r raised to n minus 1 del r by del y is the y by r plus z n r raised to n minus 1 value of del r by del z is the z by r. Now just simplify this. 3r raised to n as it is plus, now see here r raised to n minus 1 upon r, so remain the r raised to n minus 2 and x into x become the x square, so that means nx square r raised to n minus 2. મિત્રો એક એક r કટ થઈ જશે, x into x x square, so n into x square r n raised to minus 2. Similarly in remaining terms, here n into y square r raised to n minus 2 plus n into z square r raised to n minus 2. Now we just simplify this. 3r raised to n plus in these three terms take n r raised to n minus 2 outside in these three terms. So n r raised to n minus 2 take outside. So remain here the x square, here remain y square, here remain the z square. Now 3r raised to n plus n r raised to n minus 2 x square plus y square plus z square is nothing but the r square, so into r square, so is equal to 3r raised to n plus n r raised to n minus 2 into r square. મિત્રો જ્યારે આધાર સરખા હોય ત્યારે ઘાતનો સરવાળો થશે, that means r raised to n minus 2 plus 2, so here remain the 3r raised to n plus n r raised to n, here take r raised to n common, so remain 3 plus n into r raised to n, and this is nothing but our answer, n plus 3 r raised to n. So n plus 3 or 3 plus n into r raised to n. This is nothing but our RHS side. So this is the proof of our examples. Let us recall one more times. Our question is prove that divergence of r raised to n into r bar is equal to n plus 3 into r raised to n. So first of all here we find r raised to n into r bar. So as we know our vector r bar is xi cap plus yj cap plus zk cap. Now we find r raised to n into r bar. That means we multiply our vector with the r raised to n. So r raised to n xi cap plus r raised to n yj cap plus r raised to n z into k cap. Now our f1 term is the r raised to n into x, f2 term is the r raised to n y, f3 term is the r raised to n into z. Now we find divergence of r raised to n into r bar. That means here we are doing del f1 upon del x plus del f2 upon del y plus del f3 upon del z, as by apply the formula of the divergence. So here we are doing partial derivative of f1 with respect to x, f2 with respect to y and f3 with respect to z. મિત્રો આ જે ટર્મ છે x ઇન્ટુ આર રેસ ટુ એને મલ્ટિપ્લિકેશનમાં આવેલી છે અને આપણે આર રેસ ટુ એને કોન્સ્ટન્ટ ટર્મ છે એને આર ઇઝ ધી ફંક્શન ઓફ એક્સ વાય ઝેડ. સો હિયર વી એપ્લાય ધી મલ્ટિપ્લિકેશન રૂલ. આર રેસ ટુ એન એઝ ઇટ ઇઝ એક્સનું થશે 1 પ્લસ એક્સ એઝ ઇટ ઇઝ આર રેસ ટુ એનનું એન આર રેસ ટુ એન માઇનસ 1. સિમિલરલી હિયર વી ડુઈંગ રિમેનિંગ ટુ ટર્મ્સ એન્ડ હિયર વી જસ્ટ સિમ્પ્લિફાય આર રેસ ટુ એન આર રેસ ટુ એન આર રેસ ટુ એન. સો 3 times r raised to n. Now remaining term is the, here we just substitute the value of del r by del x, x by r, y by r and z by r. Now this one time r cut, so remain the 3r raised to n plus x square n into r raised to n minus 2 plus n y square r raised to n minus 2 plus z square into n r raised to n minus 2. Now we take n r raised to n minus 2 common in remaining 3 terms. So 3r raised to n plus n r raised to n minus 2 remaining x square plus y square plus z square. So this is nothing but our r square. So r raised to n minus 2 into r square. અહીંયા મિત્રો આધાર સરખા છે તો ઘાતનો સરવાળો થશે. So n minus 2 plus 2, so remain just r raised to n. That means 3r raised to n plus n r raised to n. Now take r raised to n outside. So 3 plus n r raised to n, and this is nothing but our RHS side. So this is the solution of our example. Now we see the second one. prove that, write down, prove that divergence of r bar upon r cube is equal to 0. So now we see the solution, and here we proceed as we seen in our earlier examples. So first of all, here we write the vector r bar xi cap plus yj cap plus z k cap. Now we divide vector r bar by r cube. So vector r bar upon r cube, that means x upon r cube by cap plus y upon r cube into j cap plus z upon r cube into k cap. Now we find its divergence. So here first of all write f1 is x upon r cube, our f2 term is y upon r cube, our f3 term is z upon r cube. Compare with f1i cap plus f2j cap plus f3 k cap. Now we start with the LHS. So LHS is equal to divergence of vector r bar upon r cube. So here we apply the formula of the divergence, that means del f1 upon del x plus del f2 upon del y plus del f3 upon del z. Now we find the divergence of r vector r bar upon r cube, that means del f1 upon del x plus del f2 upon del y plus del f3 upon del z. Now we are doing partial derivative of f1 with respect to x. Our f1 term is x by r cube. So del by del x by r cube plus del by del y upon r cube plus del by del z upon r cube. As you know, here we apply the division rules. So denominator as it is means r cube as it is, x નું થશે 1 માઇનસ ન્યુમેટર as it is means x as it is, r cube નું થશે 3r square અને બાજુમાં થશે del r by del x. As we know, છેદમાં છેદનું square means r raised to 6. So this is the partial derivative of x upon r cube. Similarly, here we doing remaining two terms. I repeat one more times. છેદ એમના means r cube as it is, અંશનું વિકલન એટલે x નું થશે 1 માઇનસ અંશ એમના x as it is, છેદનું વિકલન તો છેદમાં છે r cube, તો r cube નું થશે 3r square અને બાજુમાં r નું થશે del r by del x અને છેદમાં છેદનો સ્ક્વેર, so r cube નું થશે r raised to 6. Now in second one, r cube as it is, y નું થશે 1 minus y it is, r cube નું થશે 3r square into del r by del y upon r raised to 6 plus with respect to z. So r cube as it is, z નું થશે 1 minus z as it is 3r square into del r by del x del r by del z upon r raised to 6. Now observe in all these three terms 1 upon r raised to 6 take outside. So here we take 1 upon r raised to 6 common in all these terms. Now see r cube, r cube, r cube. So 3 times r cube. Through r cube plus r cube plus r cube એ થઈ જશે 3r cube. જે બાકીની ટર્મ છે એમાં આપણે જે વેલ્યુ છે સબસ્ટિટ્યુટ કરીશું. So minus x into 3r square, value of del r by del x is the x by r, minus 3yr square y by r minus 3zr square z by r. જે આપણી બાકીની ટર્મ્સ હતી એ માઇનસ એક્સ 3r square, here we substitute the value of del r by del x is x by r, minus y 3r square, value of del r by del y is the y by r, minus 3z r square and value of del r by del x is the z by r. Now just simplify. 1 upon r raised to 6, 3r cube as it is, minus c here minus 3x square, here 1r is the cut, so remain the just r. So here x square into 3 into r minus 3y square into r, here 1r is cut, minus 3z square into r. Now remaining is 1 upon r raised to 6 3r cube minus direct terms माथी minus 3r take outside, so minus 3 take outside, so here remain the x square plus y square plus z square. 1 upon r raised to 6 3r cube minus 3r, it is what is the x square plus y square plus z square is nothing but the r square. So finally 1 upon r raised to 6 3r cube minus 3r cube, answer is the 0. So this is the RHS side. So this is the solution of our second example. Let us recall one more times. So first of all, here we find vector r bar upon r cube. So write down the vector r bar, xi cap plus yj cap plus zk cap. Now we divide this vector r bar by r cube. That means we write vector r bar upon r cube. So x upon r cube y cap plus y upon r cube plus z upon r cube. Compare with f1i cap plus f2j cap plus f3k cap. So our f1 is x upon r cube, f2 is y upon r cube, f3 is z upon r cube. Now we find the divergence of r bar upon r cube. So here we apply the formula of the divergence, del f1 upon del x plus del f2 upon del y plus del f3 upon del z. So our f1 is x upon r cube, that means del upon del x, x upon r cube plus del upon del y, y upon r cube plus del upon del z, z upon r cube. Here we apply the division rules. R cube as it is x નું થશે 1 minus x as it is r cube નું થશે 3r square અને બાજુમાં થશે del r by del x અને denominator માં થશે r raised to 6. Similarly here we doing with respect to y and with respect to z. Now see 1 upon r raised to 6, take common in all these terms. So here we write 1 upon r raised to 6, r cube plus r cube plus r cube, so 3 times r cube. Now here we substitute the value of del r by del x, that means x by r, y by r and z by r. So here we substitute all this value and we just simplify 3r square, 3r cube minus 1r cut. So remaining term is the 3x square into r minus 3y square into r minus 3 into z square r. Now in these three terms take minus 3r outside, so remain the plus x square plus y square plus z square. So 3r cube minus 3r into x square plus y square plus z square, and this is nothing but the r square. So 3r cube minus 3r, value of x square plus y square plus z square is the r square. So 3r into r square is nothing but the 3r cube. So 3r cube minus 3r cube, answer is the 0, and this is nothing but our RHS side. So this is the solution of our second example. Now we see the next one. Write down the next examples. Prove that we have given capital H is equal to e raised to minus lambda x in a bracket c1 psi lambda y plus c2 cos lambda y satisfy the Laplace equation where c1 c2 lambda are constant. So this is our next question. Question is prove that capital H is equal to, here we given the scalar function in the form of H. Capital H is equal to e raised to minus lambda x into c1 psi lambda y plus c2 cos lambda y satisfy the Laplace equation. That means આપણું જે સ્કેલર ફંક્શન છે એ લાપ્લાસ ઇક્વેશન સેટિસ્ફાય કરે છે એવું આપણે પ્રૂફ કરવાનું રહેશે. એઝ વી નો લાપ્લાસ ઇક્વેશન ઇઝ del square phi by del x square plus del square phi by del y square plus del square phi by del z square is equal to 0 nebula square phi. હવે લાપ્લાસ ઇક્વેશન સેટિસ્ફાય કરે છે મીન્સ to prove nebula square phi is equal to 0. That means to prove your function satisfy the Laplace equation. હવે તમને એમ કીધું જે લાપ્લાસ ઇક્વેશન સેટિસ્ફાય કરે છે ધેટ મીન્સ તમારે એ બતાવવાનું કે જે સ્કેલર ફંક્શન છે એનો આપણે લાપ્લાસ ઇક્વેશન ફાઇન્ડ કરી તો એનો આન્સર 0 મળતો હોવો જોઈએ. ધેટ મીન્સ ટુ ફાઇન્ડ ધ વેલ્યુ ઓફ del square phi by del x square plus del square phi by del y square plus del square phi by del z square and you get the 0. That means your function satisfy the Laplace equation. Here we have given notation is the h. So here we prove our result is the nebula square h is equal to 0. So let us see solution. First of all, here we write our scalar function. We have given in a form of capital H. E raised to minus lambda x c1 sin lambda y plus c2 cos lambda y. So here we write to prove nebula square h is equal to 0. That means to prove what is the formula of the Laplace? Del square h upon del x square plus del h square upon del y square plus del square h upon del z square is equal to 0. તો મિત્રો આપણે બતાવવું નહીં રહેશે del square h upon del x square plus del square h upon del y square plus del square h upon del z square is equal to 0. So here we start our proof with the LHS side and we obtain the RHS side. So let's see. LHS is equal to now our LHS side is the del square h upon del x square plus del square h upon del y square plus del square h upon del z square. Now this is called the equation number 1. હવે મિત્રો આપણે આ ત્રણ વેલ્યુ ફાઇન્ડ કરવાની રહેશે. del square h upon del x square, del square h upon del y square plus del square h upon del z square. How to find? So we have a function h and we doing partial derivative with respect to x 2 times. So we get the del square h upon del x square. So let us find. First of all we find del h upon del x. તો આપણું જે ફંક્શન h છે એનું પાર્શિયલ ડેરિવેટિવ કેની સાપેક્ષ કરીએ આપણે વિથ રિસ્પેક્ટ ટુ x કરીએ. તો અહીં ઓબ્ઝર્વ કરો તો આપણી પાસે x વાળી ટર્મ કઈ છે e રેઝ ટુ માઇનસ લેમ્બડા x. ધીસ ટર્મ ઓનલી કન્ટેન ધી x. આ જે ટર્મ છે c1 sin લેમ્બડા y પ્લસ c2 cos લેમ્બડા y કેવી કાઉન્ટ થશે કોન્સ્ટન્ટ કાઉન્ટ થશે કારણ કે એમાં x છે નહીં. સો e રેઝ ટુ માઇનસ લેમ્બડા x નું ડેરિવેટિવ થશે એઝ યુ નો e રેઝ ટુ માઇનસ લેમ્બડા x. અહીંયા પૂર્ણ થઈ હતું બાજુમાં માઇનસ લેમ્બડા x તો માઇનસ લેમ્બડા x નું થશે માઇનસ લેમ્બડા અને આ ટર્મ્સ મલ્ટિપ્લિકેશનમાં આવેલી છે તો એઝ ઇટ ઇઝ રહેશે c1 sin lambda y plus c2 cos lambda y. As we know derivative of e raised to x નું થશે e raised to x, but derivative of e raised to lambda x નું થશે e raised to lambda x. e raised to lambda x બાજુમાં જે કાંઈ આપણે ધારેલો છે એનું થશે lambda x નું થશે lambda. હવે આપણને આપેલા છે માઇનસ so here we write the minus lambda. So derivative of e raised to minus lambda x is e raised to minus lambda x અને minus lambda x નું થશે બાજુમાં minus lambda. Now we doing again partial derivative with respect to x. So we get the value of del square h upon del x square. Again here we doing partial derivative with respect to x. So e raised to minus lambda x નું e raised to minus lambda x. ફરી પાછા બાજુમાં કોણ આવશે minus lambda અને ઓલરેડી minus lambda હતા તો minus માં થઈ જશે plus lambda square. આ ટર્મ એઝ ઇટ ઇઝ રહેશે lambda y. So this is the value of del square h upon del x square. Now we find the value of del h by del y. Now we are doing partial derivative of function h with respect to y. So e raised to minus lambda x considered as the constant term. So e raised to minus lambda x as it is. હવે મિત્રો આ બંને ટર્મ sin લેમ્ડા y અને cos લેમ્ડા y બંને y ના ફંક્શન આવેલા છે, તો એનું પાર્શિયલ ડેરિવેટિવ થશે c1 as it is sin લેમ્ડા y નું થશે cos લેમ્ડા y, અને મિત્રોની બાજુમાં શું થશે લેમ્ડા y, તો લેમ્ડા y નું થશે લેમ્ડા. સિમિલરલી c2 cos લેમ્ડા y નું થશે માઇનસ sin લેમ્ડા y, માઇનસ sin લેમ્ડા y, અને બાજુમાં લેમ્ડા y ના લેમ્ડા. So this is the partial derivative with respect to y. Now again we are doing del square h upon del y square. So e raised to minus lambda x as it is. Again here we are doing with respect to y. So cos lambda y to say minus. So minus c1 sin lambda y. And lambda y to say again lambda, but already एक lambda था, तो ये से lambda square, 2 lambda square minus c2 as it is sin lambda y નું cos lambda y, અને એક લેમ્ડા હતા ને પાછા લેમ્ડા y ના થશે. So again becomes the lambda square. So del square h upon del y square is equal to, take minus lambda square common in both these terms. So minus lambda square take outside, e raised to minus lambda x. તો મિત્રો ટર્મ કેવી થઈ જશે પ્લસ થઈ જશે c1 sin lambda y પ્લસ c2 cos lambda y. આ બે ટર્મ્સમાંથી આપણે માઇનસ લેમ્ડા સ્ક્વેર કોમન લીધા છે. સો વધશે c1 sin lambda y પ્લસ cos c2 cos lambda y. Now we doing del h upon del z. મિત્રો આપણો જે h છે એનું વિથ રિસ્પેક્ટ ટુ z કરી છે, પણ આખા ટર્મ્સમાં એક પણ ટર્મ z વાળી આવેલી છે નહીં. સો ધેટ મીન્સ ધીસ ફંક્શન ઇઝ ધી કોન્સ્ટન્ટ. તો મિત્રો એચનું આપણે વિથ રિસ્પેક્ટ ટુ ઝેડ કરી, તો જ્યારે વિથ રિસ્પેક્ટ ટુ ઝેડ કરીશું ત્યારે આખું ફંક્શન કેવું કાઉન્ટ થશે કોન્સ્ટન્ટ કાઉન્ટ થશે, કારણ કે એક પણ ટર્મ્સ ઝેડ વાળી આવેલી છે નહીં. સો ડેલ એચ અપોન ડેલ ઝેડ ઇઝ 0 એન્ડ ડેલ સ્ક્વેર એચ અપોન ડેલ ઝેડ સ્ક્વેર ઇઝ ધ 0. તો મિત્રો આપણને ત્રણની વેલ્યુ મળી ગઈ છે. નાવ વી સબસ્ટિટ્યુટ ધીસ 3 વેલ્યુ ઇન ઇક્વેશન નંબર 1. સો હિયર વી રાઇટ ડાયરેક્ટલી ફ્રોમ 1. From equation V1, LHS is equal to, what is the value of del square h upon del x square? So this is the value of del square h upon del x square. Lambda square e raised to minus lambda x into c1 sin lambda y plus c2 cos lambda y, plus value of del square h upon del y square, but value of del square h upon del y square is the, sorry, this is not a value, this is the value of del square h upon del y square minus lambda square e raised to minus lambda x c1 sin lambda y plus c2 cos lambda y, plus value of the del square h upon del z square, and value of del square h upon del z square is the 0. Now LHS is equal to, now observe, lambda square raised to minus lambda x c1 sin lambda y plus c2 cos lambda y minus lambda square e raised to minus lambda x c1 sin lambda y plus c2 cos lambda y, means બંને ટર્મ કેવી થઈ ગઈ સરખી થઈ ગઈ છે. So answer is the 0, is nothing but our LHS side. So this is the solution of our these questions. So here we get del square h upon del x square plus del square h upon del y square plus del square h upon del square equal to 0. That means h satisfies the Laplace equation. So here we write as h satisfied Laplace equations, hence proved. Now repeat one more times. To check our function h is satisfy Laplace equation or not. So that means to prove nebula square h is equal to 0. That means to prove del square h upon del x square plus del square h upon del y square plus del square h upon del z square is equal to 0. તો આપણું જે ફંક્શન h છે એનું પાર્શિયલ ડેરિવેટિવ વિથ રિસ્પેક્ટ ટુ x 2 times કર્યું છે, મીન્સ વી ગેટ ધ વેલ્યુ ઓફ del square h upon del x square. Next we find the value of del square h upon del y square, and we find the value of del square h upon del z square, and we just substitute in our formula and we get the answer is the 0, and answer is the 0. That means h satisfy Laplace equation. So this is the solution of our question number 3. Now today we stop here. In next lecture we will discuss some more examples. Thanks for watching this video. Thank you. Have a good all of you.